Okay, right. Question 2 from the A-level paper from the summer 2018. Mr. Gordon here. So curve us the equation y equals x squared minus 2x minus 24x to the half, basically. All right, we need this in indice form because we're about to differentiate it and differentiate it again, and then use those results to answer some questions. All right, so we probably should start by writing that out with some indices in the last position to make it easier. Alright, so minus 24 and the square root of x is x to the half. So we need to do dy by dx, so times by the power and reduce the power by 1. So let's do this in here. So we're going to get 2x minus 2, because that is x to the 1. So it becomes times by 1, that goes to 0. X to the 0 is 1, so it just leaves you with the 2. And then we've got minus times by the power, so times 24 by half, you're going to get 12. X, and reduce the power by 1. You're already at a half, so we're going to end up going to minus a half for that one. That's the first bit done. Second differential, so differentiate again. So I'll do this live under here, so 2x just goes to 2. We lose any constant, so this will be gone. And then we've got the last term times by the power, so minus 12 times minus half. It's going to be plus 6x. Reduce the power by 1, so I'm at minus a half, so take away 1 would be minus 1.5. And I'll write it as a fraction, minus 3 over 2. Okay, so that's the first part done. Verify that C has the stationary point when x equals 4. Stationary point basically means we've got a gradient of 0. So we're going to potentially have this situation here where the gradient is 0 on the curve somewhere. So this is the gradient function, isn't it? Dy by dx, this is our gradient function here. So we're going to use this one. And so I'll write this out. I'll pull this out here and we'll substitute x equals 4 into the gradient function to see what happens. So we're going to end up with 2 lots of 4 minus 2 minus 12 lots of 4 to the minus a half. Okay, and what does that look like really? So you've got 8 minus 2, and this needs to be sorted out. So the square root of 4 is 2, and 2 to the 1 is 2. A minus 1 means you take the reciprocal, doesn't it? So this indice part here is going to give us a half. Okay, because square root of 4 is 2, 2 to the 1 is 2, and the minus takes the reciprocal. So it's basically minus 12 times a half, which is going to be minus 6. And that equals 0. So that is what we had to show, that the gradient is 0 when x is 4, and if we put 4 into the gradient function, we do get 0. So that is enough to show, to verify that C is a stationary point. The second part is determine the nature of this stationary point. Give a reason for your answer. Well, the second differential, this is what we use to determine the nature of a stationary point. And again, we're just going to put in our value 4 into this and see what happens, alright? So I'm going to write this out first, is 6 plus, I'm going to write this like this, 6 over x to the 3 over 2. Alright, I've sorted the minus sign out first. I've rewritten it back in this form here. So there's no need for the minus sign because I put it to the bottom of the fraction. Put 4 in. 2 plus 6 over, and we're going to have 4 to the 3 over 2. So this is the same as, just do a little thought bubble here, 4, the square root of 4, because that's the 2 part on the bottom, cubed. That's the 3 on the top. That's what it's going to do. Square root of 4 is 2. 2 cubed is 8. So we're going to end up with 2 plus 6 over 8. This is all positive. And that's what we're interested in. Do we end up with a positive answer or a negative answer? If we get a positive answer, it means the gradient around this point here, that we just showed that was a stationary point, the gradient around this point is the rate of change is always positive. So it's always becoming a less negative. And if it's always becoming less negative, then it is going to be a minimum point. Okay, because it's going to start with a gradient that is negative, but it's trying to get less negative, and it's trying to turn into a positive gradient all the way around this point, positive, until it finally becomes positive. There's our x equals 4. Our stationary point is here. And the gradient around this point is always becoming less negative, less and less, until it turns into positive and gets more and more positive. So a minimum point. This is a minimum point. Okay, hope that's been helpful. On to the next question.